Hello dear learners, in this video we will start with the unit 7 of Biostats, and the unit talks about the correlation. So in today's video our main aim would be to understand what is correlation and what kind of questions can be asked from this topic. So basically we can say that correlation is a statistical method, and when we have two variables, even more than two variables, and when we need to study the relationship between the two variables, the relationship can be studied easily by correlation, and this relationship is only the correlation between the two variables. So if we take the example of height and weight, so suppose we consider height to be one variable and weight to be another variable. So with the time, if the height of a person is increasing, the weight of the person will obviously increase. So there is a correlation between the height and the weight. Similarly, increase in smoking can cause the increase in chances of lung diseases. So we say that correlation talks about the relationship between any of the two or more than two variables. And basically we need to check whether the two variables are directly proportional to each other or are they inversely proportional to each other. So it is measuring the association between the variables. It does not prove any cause and effect relation, but just is trying to sort and clarify whether the two variables are associated or not, and this it will do by numerical analysis. So if we assume two variables, one of them being x and the another one being y, so generally we take the letters, we designate the letters for the variables, let the letters be x and y. Let's consider x to be the study hours and y to be the marks obtained. So we can say that if the study hours are increasing, means if the x is increasing, so with the time y also has to increase. So if the both of them are increasing together, we say that there is a positive correlation between them. Now this is a very generalized statement. It is very obvious that both of them will increase with time, are dependent upon each other, and they will have the positive correlation, but this can also be expressed numerically, and we are going to understand it further. Now there are many types of correlation, so we have to understand them. So first category can be on the basis of direction of relationship. So suppose we say that when the two variables are increasing together, that means if the one variable is increasing, the another variable will also increase. Or else, if the one variable is decreasing, the another variable also has to decrease. In that condition, the correlation between them will be the positive correlation. Suppose if the income is decreasing or the income is not high enough, the expenditure will also decrease. If the rainfall is not high enough, the crop yield will decrease. So we can understand this positive correlation in the either sense. So if one is increasing, the other has to increase, or if the one is decreasing, other has to also decrease. Graphically, the points will move upward from left to right, or even they may decrease from left to right, depending upon that are the two increasing or are the two decreasing. The next of them being the negative correlation. Negative correlation means that if one is increasing, the other has to decrease, or if one of the variables is decreasing with time, the other has to increase. That is, the inverse relationship can be denoted by the negative correlation. Now the example being the price and demand. If a price of something or an object is increasing, the demand of that object with time will decrease. So this is the negative correlation, and the points will move downward from left to right. Now if we assume zero correlation says that when there is no relationship between the two variables, the correlation will be zero. Okay, one more important thing is that in the case of positive correlation, either the two things are decreasing or the two are increasing, the graph will be this way only. And in the negative correlation, either it can be this or it can be this also, but the graph will be in this slope. So it depends. Then the zero correlation is when you do not have any relationship between the two variables. So this is based upon the simple relationship between the two variables. The next category can be, for classification of correlation, can be the basis of the number of variables. So if we are considering or we are taking only two variables into account, we say that this is a simple correlation, like height and weight. If we are taking multiple variables into account, we say it is a multiple correlation. If we are taking two variables which can change with time, but the other variables have to be constant, means we are taking the multiple variables, but many of the variables out of these multiple variables are made constant and only two of them have to change with time, then this is a kind of partial correlation. Okay, then another category can be on the basis of relation, that is linear correlation or the non-linear correlation. So suppose if the two of them are two variables x and y are increasing over a fixed period of time, and over a same period of time they are increasing constantly, that time we say that they have the linear correlation. If it does not happen, then the correlation will be non-linear. All of these things can be easily understood by the scatter diagram. So in the scatter diagram, what do is we plot the two axes x and y, and let's assume this x to be variable 1 and y to be variable 2. Now we will be provided with a data set, and then we have to mark the positions of x with respect to y on the graph. So if this type of data comes, so we can simply say that it is the positive correlation. Now some correlations are there which may be positive but not perfectly positive. So on that basis, we can say that the correlations can be perfect positive correlations, perfect negative correlations, high positive means near to perfect positive, and high negative, which means near to perfect negative, and fifth of them being zero correlation. If all the points exactly lie on the upward straight line, if we are trying to plot this, we assume that this should be the standard line and all the points are directly coming onto this. We say it is the perfect positive correlation. If we are assuming the downward line and we say all the points are coming onto this, we say it is a perfect negative correlation. If we are assuming this line but the points somehow come like this but going along with the line, we say it is a high positive, and vice versa for high negative. And zero correlation, if we are trying to plot any kind of line but the points do not come at all in the way of the line, we never know that where are the points go, so that will be the zero correlation. So these are also the various kind of correlations, and you can directly identify such kind of correlations by looking over at the scatter diagram. Now we should come to the next topic, that is correlation coefficient. What is the meaning of correlation coefficient? Now this coefficient is denoted by the symbol R. It is trying to measure the degree and the direction of the relationship between the two variables. Degree simply refers to the magnitude, means how much are the two variables related, and direction refers to that are the two variables related in a positive way or in a negative way or in a neutral way. So both magnitude and direction will be given by the coefficient of correlation. Now the value of this correlation coefficient, that is the value of R, can lie in the range of -1 to 0 to +1. In this range only it will lie. If it is +1, we say it is a perfect positive correlation. If it is -1, it is perfect negative correlation. If it is here, so we say highly positive correlation. If it is here, then we say highly negative correlation. And if it is here, we say there is no relation, or we say that there is a zero correlation. Now the formula to calculate the correlation coefficient has been given here. So let's try to understand the formula. Okay, so the formula is quite simple. Now as I told you that in the data, even in the numericals, they will provide you two data sets. One of them will represent simply the wait yes, one of them will simply represent the variable x, while the another one will simply represent the variable y. Now if you take out the mean of x, which can be x1 plus x2 extending till xn upon n. Similarly, if you take out the mean of y also, and then when you do the subtraction of the total value of x from the mean, similarly the total value of y from the mean of the y, and then even you square them by preparing a proper table, you can easily derive out the correlation coefficient magnitude. Now suppose the magnitude of correlation coefficient comes out to be 0 plus 0.85. So from here we can derive two things. One of them, this plus will denote the direction. That are the two positive in the positive direction? Yes. And 0.85 can denote the magnitude or can denote the degree, and we can say that they are highly positive but not perfect positive. Perfect positive in the case when the correlation coefficient comes out to be 1. So I have written here also all these things. So supposedly if the value comes out to be plus 1, we say perfect positive correlation. If it is negative 1, then it is perfect negative correlation. No correlation when the value comes out to be 0. Near to plus 1, then it is strong positive correlation. If it is near to negative 1, then it is strong negative correlation. And if it is near to 0, it is a weak correlation. So if we need to understand the characteristics of correlation coefficient, the values will always lie between -1 to +1. If there is a positive value, the direction is direct. If the negative value is there, the direction is inverse. The magnitude will indicate the strength or the degree of the correlation. It is always independent of any units of measurement. It has no unit. It measures only the linear relationship. Now let us try to calculate the correlation coefficient here by this data. Suppose we have the value of x here. This is a variable 1 and it has the following values, and y has the following values, and now we need to calculate the correlation coefficient, or we need to calculate r. So how are we going to calculate? See, first of all we need the summation of x, then we need the mean of x, then we need summation y, we also need the mean of y. Then we will calculate x minus x bar for individually, and then we will do summation of x minus x bar. Similarly we'll do y minus y bar, and then we'll also do summation of y minus y bar. So first of all they've calculated the mean of x, which comes out to be 5, and the mean of y comes out to be 7. Now they have noted all the values of x and y here, and then they had started calculating x minus x bar, y minus y bar. The next thing which they did was the product of two of them. So minus 3 comes out to be 9, minus 1 comes out to be 1. Similarly 1 and 1 comes out to be 1, and 3 and 3 comes out to be 9. Then they individually squared the difference also. So here x minus x bar, it's a square they have done. So minus 3 square is 9, minus 1 square is 1. Similar is applied here also, and same for y. Now they have put the formula. We already know what the formula is. The formula was summation of x minus x bar multiplied by y minus y bar. So whatever this came, first you have to summate it, then upon, then root of x minus x bar, whatever the answer came, its square has to be done, multiply by whatever the summation of y minus y bar came, its square has to be done. So summation of x minus x bar came something, and its square comes out to be 20, and for y also its square comes out to be 20. So what they have done finally, they have calculated the coefficient of correlation, and it came out to be how much? So the summation of the two products, or the products of two differences, so it is 20 upon root of 20 multiplied by 20. So the final answer comes out to be plus 1. Plus will indicate the direction and 1 will indicate the magnitude. Now we need to understand the probable error of the correlation coefficient. So if we need to understand this probable error, and firstly we should see that why is this error calculation also required. See, if now there are the chances that every statistical calculation has some kind of error. So if this probable error comes out to be greater than the correlation coefficients, and more or less we can say that there is no significant correlation. correlation is not there. And when the correlation coefficient comes out to be greater than the probable error, we can say that correlation can be there. This correlation will be confirmed when the correlation coefficient is greater than 6 times the probable error. So if this is the case, then we say that there is definitely the correlation between the two variables. Now it can be either positive correlation, negative correlation, but it will be there. And in this condition, we say that there is zero correlation. Okay, now this probable error calculation, how do we do this? So it is 0.6745. See, 0.6 multiply by 1 minus r square. What is r? R is the correlation coefficient upon root of n, and n is the number, the total number of observations which you are taking into account. Now let us try to calculate this with the help of one of the examples. So here is problem 1. So there is a physiology researcher. He recorded the average daily exercise duration of 5 individuals. So he took how many individuals? He is taking 5 individuals here. And okay, this is simple correlation coefficient calculation only. I assume that you guys can easily solve this question because I've already explained the procedure that how to solve problem 1 and problem 2. Let's jump on to this problem which talks about the probable error of correlation. So nutrition scientists examine the association between protein intake and hemoglobin level among 25 individuals. So here are number of observations n equal to 25. And the computed coefficient describing the relationship between the two variables, let's say this is the x, protein intake is x variable, hemoglobin level is y variable. So the correlation coefficient between them means r between them is 0.72. Now we have to determine whether the observation association may be considered reliable statistically or not. Means, is there any coefficient correlation? Means, is there any correlation or not? So we need to calculate the probable error first. And as I told you, it is 0.674 multiplied by 1 minus r square upon root of n. Now it can be equal to 0.674 multiplied by 1 minus r, and r is 0.72. N is 25. Now we need to calculate this with the help of a calculator. After solving the question, the answer of the probable error comes out to be 0.06. Now what is 6 times of this? Means 6 times of 0.0649 comes out to be 0.3894. If the correlation coefficient is greater than this value, that is 6 times PE, then we say the results are significant. Let's see, the correlation coefficient was 0.72, and obviously 0.72 is greater than 0.38. So we say that there is a correlationship between x and y, and we say that the correlation is statistically significant as well as reliable. In the very similar way, you can do this question also. Now there are two important questions which we can be solving right now only. So one question is that a researcher is studying the environmental physiology, and he recorded the atmospheric humidity levels and average water intake of the laboratory animals over 6 different days. So basically the variable x here is humidity, variable y is water intake. Now we have to analyze statistically whether the two characters exhibit any association or not. So we have to calculate r. So what we are going to do, first we'll note down the values of x and y. So suppose the values of x comes out to be 40, okay, 50, then 55, 60, 65, and the value of y 18, 20, 23, 25, 28, and 30. So these you have noted. Now what you need to do? You have to calculate the mean of x, which will come out to be 40 plus 45 plus 50 plus 55 plus 60 plus 65 upon how much? 6. Mean of y comes out to be 18 plus 20 plus 23 plus 25, 28, 30 upon 6. So a specific value will come for this and a specific value will come for y also. Now you have to do here x minus the mean of x. Here you will do y minus the mean of y. Then in one column you will multiply the two values. Then in one column you will do x minus x, the mean of x, it's a square. Then in one column you will do the square of y minus the mean of y. Now from here what things you require? Firstly you require the summation of the two, summation of the product of these two differences. Basically whatever the values are coming here, just add them to get this. Then also do the summation here. Whatever the values come, just add them, and whatever the values come here, just add them to get this. Now calculate the correlation coefficient, which can be equal to summation of this value upon root of this value multiplied by this value, that is summation x minus x bar square multiplied by summation of y minus y bar square. Now try to find the correlation coefficient. Whatever the answer comes will tell you whether the two of the variables are directly related or inversely related, positively related or negatively related. One question we can also do for this. So in a nutritional survey of 49 individuals, what is given here? So there are 49 individuals, we can consider n to be 49. The coefficient representing the relationship between daily calcium intake, which can be considered x, and the bone density index considered y, obtained as 0.58. So R is 0.58. You have to evaluate whether the observed relationship may be accepted, that is accepted as statistically meaningful or not. So basically we need to calculate the probable error, and now we need to find the probable error. It is 0.674 multiplied by 1 minus r square upon root of n. Putting the values 0.674 multiplied by 1 minus 0.58 square upon root of 49. 0.674 multiplied by 1 minus 0.58 square upon 7. Now try to calculate this. This will be giving you the answer for probable error. Then the question doesn't stop here. You have to multiply this probable error with 6. Now if your r is coming, the value of r, which is 0.58, if it is greater than 6 times of this probable error, that time you can say that this is statistically meaningful. And if the 0.58 value is smaller than what is coming after calculating 6 times the probable error, then you say that the correlation is statistically not meaningful. So this is how you do the questions and the problems related to the correlation, correlation coefficient and the probable error.